Okay. Reviewing 9.4 stuff. So first of all, I didn't realize that there was going to be some problems quite to this caliber. This one's not bad. So let's look at this one. If I said to you expand the logarithm, remember there's only 3 basic rules. You can split apart if you have multiplication, division, correct? And then exponents become multiplied in front. You cannot split apart addition and subtraction, right, everyone? Yep. Okay, so we would rewrite this as log to the base 2 of x squared. In a minute I'll fix my exponent. Then multiply, you add, plus log to the base 2. And shouldn't I write that as x squared plus 25 instead of square root to the 1/2? Is any questions so far? Minus log to the base 2 of x minus 1. That is our first step, and then taking your exponents down in front. So now we have a 2 down in front and a 1/2 down in front here. We would not split apart addition and subtraction, correct? Okay, now here's the thing. I didn't realize there were going to be some that could end up having some more simplification. So let me show you. This quadratic does not factor. What multiplies to be 25 and adds up to be 0, nothing. Because 5 times -5 would need to be -25. So if you look at this problem, this one actually would split up to be a little bit more than the last one. Here's why. So if you have a quadratic that factors, you're going to want to write it in factored form, because then that's 2 things being multiplied. If you have 2 things being multiplied, can't you split them apart with addition? Yeah, so you've got to check into your logarithms. If it says expand, do any of my quadratics factor? So let's factor that. Well, multiply to be -25, adds up to be 0, 5 times -5, right? So then we have this, log to the base 2 of x squared, square root of x plus 5, x minus 5, and then all over x minus 1. Now one more time, just a reminder, this is an exponent, really, so we actually have log to the base 2 of x squared, and then don't we have x plus 5 to the 1/2? And then x minus 5 to the 1/2. Am I breaking a forbidden rule by doing that? No, because it's a multiplication sign. And then all over x minus 1. So now we can split it apart. So do you see how this one actually splits apart a lot more than that last one? Because of the factoring thing. Okay, so then this one would be, I'm going to hit 2 birds with 1 stone. 2 log to the base 2 of x from that. Then we have plus 1/2 log to the base 2 of x plus 5 for that. Plus 1/2 log to the base 2 of x minus 5 for that. And then minus log to the base 2 of x minus 1. So the general thing here is to make sure if you have a quadratic inside to factor it. Okay, everyone good? Okay, next thing. Moving on to today's lesson. Here are the steps we take to solve a logarithmic equation. We're going to be solving logarithmic equations and exponential equations today. So it kind of follows the same theme that we've seen throughout the year. If we're solving a radical, we isolate the radical. So right here, isolate the logarithm. Now notice there are 2 logarithms. With this one, we're going to want to bring all the logarithms to one side of the equation. And anything that doesn't have a logarithm on the other side. Then second, we're going to put our logarithms together so that we only have 1 logarithm with properties of logarithms. And then third, undo the logarithm with the correct inverse, which is what undoes log base 4, a base 4, for example. And then fourth, just solve your equation with correct algebra. Now think about it, with log equations, we do have to check our answers, because if we get an answer that when we plug it in, it makes it negative or 0 inside our parentheses, it would be considered extraneous. So let's follow these steps. In this first equation here, it says isolate the log. So we got to bring all the logarithms to one side. So I'm going to add that to the other side. So now we would have log to the base 4 of x minus 6 plus log to the base 4 of x equals 2. Any questions? Now watch. Everyone listen, this is really important to understand. I don't want anyone to do this on the test. It is not okay to say I'm going to base 4, base 4, base 4. Yes, I did it to every piece, but you just broke what's equivalent to the forbidden rule. Let me explain. If I have x plus 1 to the 4th power, I know I can't just 4th power that and 4th power that, correct? Because there's an sign. We have an addition sign here. So base 4ing across an addition sign is equivalent to just exponenting each piece. Does that make sense? Exponenting. I can't figure out how to say that. Struggling. So instead, we're going to use properties of logarithms to put this together. If we have two separated logarithms, we can put them together. If it's addition, it's multiplication, right? So this is log to the base 4 of x minus 6 times x, is it not? Equals 2. And now because I only have one logarithm, we can undo the logarithm with a base 4 to both sides. So now base 4, log to the base 4 cancel out. So then we have x minus 6 times x equals base 4 squared. People were asking me, well, which one's the base? Well, base 4 is base 4. Base 4 squared is 4 times 4. Or 4 squared 16. Do you agree? Now solve using algebra. So you would need to distribute. So you have x squared minus 6x equals 16. Solving a quadratic, we get it equal to 0. X squared minus 6x minus 16 equals 0. So then you would do what multiplies to be negative 16 and adds up to be negative 6. 8 times 2, negative 8, positive 2. It quick factors to be x minus 8, x plus 2. So my two solutions are x equals 8 and x equals negative 2. Now do not just assume because it's a negative answer that it's going to be extraneous. What you got to do is take both answers, plug them into the very first original, and if it comes out negative or 0 inside, it is extraneous. If I plug in an 8, won't it be positive 2 inside? If I plug in 8, we're all good. If I take negative 2 and plug it in, won't it be negative 8 inside? That can't happen. So that one is extraneous. Negative inside the parentheses when you plug it back in.
Also, we don't have to solve the whole thing.
No. And see how if we plug in negative 2 right there, it's negative inside? So we know it's extraneous because that can't happen. But we're not going to just assume, because what if I would have plugged in 8 and got a negative? Then that one would have been extraneous too. Okay, any questions on that? Pretty easy. Okay, now we're going to do, this is really the last part of the lesson, and the rest of the time will just be practice a bunch of different types. So solving exponential equations, follow the same steps. First, isolate the base completely. I always have people say, well, what's the base? The base is the part that has the x in the exponent. That's the base. So get the base completely by itself, then undo the base with the appropriate logarithm. Then we're going to have to do a change of base formula so we can calculate it and then solve using algebra. So first step is to say, well, my base in this one is base 5, is it not? That's the part that has x in the exponent, so isolate it. So the first step is to subtract 1. So we have base 3 times 5 raised to the x minus 1 equals 6. Next step, divide by 3. So then we have base 5 raised to the x minus 1 equals 2. Any questions so far? Now you'd say to undo a base 5, you can't divide. You have to undoing a base is not divided by 5. It's log base 5. So log base 5 both sides of the equation. Log base 5 and base 5 cancel out, giving me an x minus 1 on the left. And on the right, everyone, this is what we have. Log base 5 of 2. Before you move on, you need to realize this cannot be calculated as is. We need the change of base formula. Remember, the change of base formula allows us to rewrite this as base 10 so our calculator can calculate it. This can be rewritten as log of 2 divided by log of 5. It's always log of what's in the parentheses divided by log of the base. So now from there, to solve for x, won't we just add 1? So x is equal to log of 2 divided by log of 5, and then plus 1. There's our exact answer. I want an exact answer and a decimal. But yes, I do want that exact answer. Yes?
So is the change of base formula, is it just put the...
Whatever's in parentheses always goes on top. So everyone practice typing it in so that you know on the test, you know how to type it in. Log of 2 divided by log of 5, hit enter, plus 1. I get decimal, you would write down the full decimal, 1.430676558. That would be your answer. Both of those, exact answer and decimal. So pretty easy as long as you follow those steps. Now we're just going to do a ton of examples. actually solve. All right, we have a log. Now, do not be tempted. Now, with this one, there's two ways to solve. Do you see we have only logarithms and nothing else? You can bring all the logarithms to one side of the equation. That is one way of doing it. And then, if we did it that way, wouldn't there be a 0 on this side if we brought this over? You could do that. That's fine. Or, if there's only logarithms, you can actually leave logarithms on both sides of the equation. So I'm just going to leave it. Now here's the thing, you cannot base 3 it because then you are pretending like that 2 is not there, and it is. So what we need to do is we need to fix the 2 first. So just a reminder of properties of logarithms. If we have something multiplied to a logarithm, it is equivalent to an exponent. So that's our first step, is to rewrite it. So we actually have log to the base 3 of x to the second power equals log to the base 3 of 25. Now, notice you have log base 3 and log base 3, nothing connected to either of them. Do you see? So now we can undo it with base 3ing both sides. Base 3 and log to the base 3 cancel out, so we have x squared equals. Base 3 and log to the base 3 cancels out, so equals 25. So now from there, solve for x, you'd say I have a quadratic. I can solve quadratics by factoring and getting a set equal to 0, or in this case, couldn't I just take the square root? So square root both sides. So x is equal to plus and minus 5, checking our answers. X equals 5. If I plug in 5 right here, will it be positive inside? If I plug in negative 5 right here, will it be positive inside? No, you got to plug it in right here in the very original. Do you see how it would be negative? So that means we would throw out our negative solution, so only 5 would be our solution. So yeah, so far we've seen that all of our negatives have happened to be extraneous, but that's not always going to happen. Okay, let's do another one. Okay, actually, you guys do this one by yourself, because this is no different than what we just did a second ago. So get it to be, make sure you don't just base 2, base 2, base 2, because you can't base 2 across an addition sign. So get that to be one logarithm. Put it together with properties of logs is your first step. Then we would undo log base 2 with a base 2. Do you agree? Yes. Most of you that understand how to do it are there. So then we have our x times x minus 2 equals 2 to the third power, which is 8. From there you would need to put it in standard form, x squared minus 2x minus 8 equals 0. Awesome, I saw a few of you get there. Then you would solve by factoring. What multiplies to be negative 8 and adds up to be negative 2, 4 times 2, 4 times 2, negative 4, correct? Yeah. Quick factors to be x minus 4, x plus 2. Therefore, my two solutions are 4 and negative 2. Any extraneous ones? Negative 2, because if you go plug in negative 2, we now have negative 4. Inside a logarithm, can't happen. 4, plugging in 4, 4 minus 2 is 2. Plugging in a 4 here is just 4, so all is good with 4. How many of you were able to get it? Awesome, yes.
So, you put it in some form after...
After getting rid of the logarithm?
Yes, so it wasn't necessarily wrong, but I started putting it in some form after I put the logarithm together.
So this is a great question. So remember that standard form and factored form are equally good, so it would also be appropriate to have it in standard form there. It doesn't matter. Right. Good question. Okay, another one. Here we go. All right, so solve for x. Isolate the base, undo the base, solve for x. Do you want to try it by yourself? Okay, go for it. Okay, first step is to isolate the base. So you'd subtract 2. So then you have base 3 raised to the x equals 5. Then you'd say, I need to get x out of the exponent, so I'm going to have to log base 3 both sides. So now over here, log to the base 3 and base 3 cancel out. So x is equal to log to the base 3 of 5, which would be the change of base formula. So we know we can rewrite that as log of 5 over log of 3. There's your answer, because then x is alone. And then you get decimal 1 point. Perfect. Do we have questions on that, guys? Isolate the base, undo the base, change your base formula, solve. Okay, awesome. Question?
I'm not sure where the one came from. I'm using the same decimal.
Log of 5 divided by log of 3. Are you sure you're not getting a 1?
Maybe I'm okay.
Make sure you close your parentheses after log of 5. Okay, try another one by yourself. Go for it. Go for it. Go for it. All of them. All right, so let's solve. So your first step is subtract 1. Base 5 raised to the 2x equals 3. Log base 5 both sides. So then you have 2x equals log to the base 5 of 3, which now needs to be written as log of 3 over log of 5. And then I'm going to show you something interesting. So then you divide it by 2, correct? Okay, now fun fact for you. If you were to see this on a multiple choice test, they would not write it like that. Or if you were, and some of your tests might be multiple choice for the final. So let's think about, that is correct. If you type that into your calculator, you would get 0.341303097. Yes, correct. Now here's the thing. Equivalently, mathematically, what is this the same thing as? Well, dividing by, times by a half. You're right. This is the same thing as 2 over 1, correct? So then you would see on a multiple choice test, then take and flip and multiply. So dividing fractions is easy as pie. Flip the second fraction, which is 1/2, or 2 over 1. Flip it to be 1/2 and multiply. So this is how you'd see them write the answer. 1 times log of 3 is log of 3. And then on bottom you have a 2 times log of 5. It mathematically calculates to be the same, so it is okay. But just I need you to understand if it was multiple choice, you'd see it like that. Okay?
So when you have the actual like 0.341.
It might, but usually no. Okay, awesome. Next one. Okay, let's do this one together. So, isolate the base. The base is e. So what would I do first? Divide by 4, then see if your fraction simplifies. Base e to the 3x equals, what does 10 over 4 simplify to be? Good, 5/2. They both divide by 2, 5/2. So this is 5/2. What undoes an e? ln both sides. ln and e cancel out. So we have 3x equals ln of 5 over 2. Now don't be mistaken. This is not equivalent. You can just type in ln of 5. We're not done though. We're not done. But understand this is not equivalent. ln of 5/2 is not the same as ln of 5 divided by ln of 2, is it? What is it equivalent to if we want to be really technical? ln of 5 minus ln of 2. But we don't need to even do that because our calculator has an ln button. So divide by 3, divide by 3. So our answer is x is equal to that. ln of 5/2 divided by 3. So then type into your calculator ln of 5 divided by 2 and then divided by 3. And you get the decimal 0.305430244. Would the what?
Would the 3 be for the ln?
Well, it's 1/3, right? So maybe a third, but it wouldn't be 3 because that would be different. Yes, good question. Because this one's not a fraction divided by a fraction, right? Because ln of 5/2 is all connected. Does that make sense? So an equivalent answer would be, it would probably be on the test, yes. But to answer your question, yeah, 1/3 ln of 5/2. Do you get what I'm saying?
Yeah.
Because this isn't 2 separate fractions. Good question. Okay, awesome. Next one, do by yourself. Go for it. great question. So, I'm glad you asked that. Hold on. Is that your answer? Okay, now I got asked a really good question. Can I have a negative answer in this equation? Isn't this an exponential? Exponentials. Can't we plug in positives into exponents? Can't we plug in negatives into exponents? We can plug in anything into exponents. So there wouldn't be extraneous, yes.
Why is it being answered like a
It
decimal?
is. So ln.
So technically.
ln of 20 divided by 3, I just didn't write it down, divided by negative 4, you would get the decimal, but once again, I want the exact answer. Most importantly, you get negative 0.4742799996. Yes. So, yeah, good question. So your official, I see what you're saying, it's not necessarily pretty to have a negative on bottom, so maybe put it up here and make it positive. Yeah, then you'd get brownie points on the test. Okay, good. All right. Do this, okay, let's do this one together. Here we go. When you subtract, you divide. So let's put this bad boy together. Don't do base 3, base 3, base 3. That'd be breaking the forbidden rule. But it is log the base 3 of x plus 5. When you subtract, you divide over x equals 2.
Yay.
Yay, now what? Base 3. So base 3 and log the base 3 cancel out. So we have x plus 5 over x equals 9. Then I don't know why people freeze right here. Cross multiply or get a common denominator, right? Then it's a rational equation. So get a common denominator times by x over x. And then can't we ignore our denominator? So then we have x plus 5 equals 9x. So then solve for x. Subtract x. So then we have 5 equals 8x. Divide by 8. So x equals 5 over 8. Then we'll check this one since it's a logarithm. If I plug in 5/8, 5/8 plus 5 is positive. 5/8 is positive, so we're all good. Okay. Do we have questions on that one? Okay, let's look here. There's a reason I want to do this one together. So, still is it okay now because there's all logarithms? Base 4, base 4, base 4? No, because that's breaking it because of the plus sign. So hurry and put this side together. So we would have log to the base 4 of x plus 3 times, because add means times, x minus 6 equals log to the base 4 of 3. Now can't we undo log base 4? Base 4, base 4. So now that's gone. So then we have x plus 3 times x minus 6 equals 3. Now when we have a quadratic, we need to put it in standard form. So x squared minus 6x plus 3x minus 18 equals 3. So now quadratics, get it in standard form. So x squared minus 3x, and then negative 18 minus 3 is negative 21. Now in this case, our quadratic does not factor. If you tried, 1 multiplies to be negative 21 and adds up to be negative 3, nothing. No fret, because we know how to solve quadratics that do not factor. Quadratic formula. Now listen though, if we were to do quadratic formula and get i's, no solution. We can't have i's in logarithms. However, if we do the quadratic formula and we get not i's, it's okay to have solutions like that. Now, you guys, if you don't know the quadratic formula right by now, you need to know it. So I don't even know how you made it this far as it is if you don't know the quadratic formula. Figure it out, okay? Learn it. Here we go. X equals, and I'm not just saying that to be mean. I'm dead serious. On the test, people did not even know the quadratic formula. It's not that they had a hard time calculating it. That's understandable. They didn't even know it. They're like, x equals, I don't know. If you don't know the quadratic formula, go home and memorize it. X equals negative b, which would be positive 3 plus or minus the square root of b squared minus 4 times a times c, all over 2a. So now, is this positive? If so, we got to keep going. 3 plus or minus the square root of 93 all over 2. Now we're going to split it up. We have two solutions. So we have 3 plus root 93 over 2, and we also have 3 minus root 93 over 2. Now we're going to get that's our exact answers. Let's get our decimals. So you would have to do, everybody listen to what I'm about to say. If you just type in 3 plus root 93 divided by 2, it's going to calculate it wrong. You have to hit enter. 3 plus root 93, hit enter, then divide by 2. You get let's round this one, 6.3. If you do 3 minus root 93 divided by 2, you get negative 3.3. Let's check. If I plug in 6.3, will it be positive in my logarithm? 6.3, plug it in. 6.3, all is good, correct? Plug in negative 3.3. Plug in negative 3.3. Isn't it negative inside? Yeah. So only keep, you would give me the exact answer and the decimal answer. So we would throw out our negative one, the one that became negative, and we would keep this bad boy right here. All right, doing good. Do that one by yourself, go. You bring 5 up here, right? That'd be your first step. Don't base 4 it with that 5 there. Awesome. So we bring our 5 up, then we undo it. We get x equals.
What?
What's our answer?
Oh, answer's 2.
2.
I was like,
You're going to put your 5 up there.
So you have log to the base 4 of x to the 5th equals log to the base 4 of 32. Undo it with the base 4.
You're left with x to the 5th.
X to the 5th equals 32. 5th root that bad boy. X equals 2, but not plus or minus because odd roots don't get plus or minuses. Okay, awesome. Again, go again, go again. Check your answer when you're done. Yeah, I'm going to just show you something interesting that happens on this next I'm not going to have you do it. I'm just going to show you. Okay, were we all able to get to our final answer?
Yes.
Log of 2 divided by 3 divided by log of 2 plus 1. Okay, awesome. I'm not going to do the decimal answer, but we would know how to calculate it. Let me show you something interesting that happens on this other one right here. I just thought of this, because you could run into this. If I said solve, you'd say, okay, I subtract 8. Watch what happens. 2 to the x minus 1 equals negative 1. Log base 2 both sides. Oh, log base 2 of a negative. Can we even log of a negative? No, you're right. So there would be no solution. Negative inside a log. Okay. Okay, let's look at another one. This one we need to do together, right? All right.
It's already, dude, it's been back for like, how long?
So what would we do to this one?
We're just not public.
she's recording, guys.
Log a third? Okay.
Oh.
Log base a third. Log base a third. So now that undoes that. So we have 4 over x plus 1 equals log base a third of 2. Does not need the change of base formula. So 4 over x plus 1 equals log of 2 divided by log of a third. Solving for x. What would I do next? Yeah, get a common denominator or cross multiply. Cross multiply is the exact same thing as getting a common denominator. It's just you've learned a trick to do it. Okay, So everybody, yes, get a common denominator or cross multiply, because then that'll bring x out of the denominator, correct? So multiply by log of 1/3, or sorry, log of 1/3, log of 1/3, multiply by x plus 1, x plus 1, right? Now we can ignore denominators. So then we have 4 log of 1/3 is equal to log of 2. Now keep in mind times x plus 1. Keep your goal in mind. Keep your goal in mind. I am trying to get x a. Yep, divide by log of 2 and then subtract 1. That would be your exact answer, then you'd have a decimal. Do you need to practice getting that decimal, or do you think you're okay? Okay, go for it then, like a maniac, go. So my point is, the dividing by a half, we need to start thinking of undoing that by timesing by 2. That's going to be prettier. You do it on your own, everyone. It down. We're almost done actually, but just these last ones you have to see, or else you won't be able to do it. So notice we have 2 different bases, and they both have x's in the exponent. So the problem is we are not able to rewrite it. Like, let's say that the 3 was an 8, then it would be fine, because couldn't we write that as a base 2? But it's not. So the problem is we can't rewrite both of these as the same base. So you're going to have to choose. I'm going to undo base 3 or base 2, and it is what it is. So here's what I always undo. It doesn't matter though. I can undo a base 3 or a base 2. Mathematically it'll work out the same. Here's what I choose. I always undo the base that has the ugliest exponent. So this one is the biggest exponent, so I'm going to undo base 3. So that means I'm going to log base 3 both sides. Because you got to do the same thing to both sides. So log base 3 and base 3 cancel out. So then we have this. X plus 1 is equal to log base 3 of 2 raised to the x power. Now keep in mind your goal. I need to solve for x. X is in the exponent, so I need to bring it out of the exponent. Now if I have people say, so what you're going to do is base 3 both sides, but then you're right back to the beginning. You see that? Yeah. Yes, let's take this x, because that's an exponent, and put it in front of the log. Way to think. So we have x plus 1 equals x log to the base 3 of 2. Okay, next step. Okay, this is a good question. If I divide by x, is this side going to be any prettier? No, but that's actually what a lot of people want to do. That's not it, though. But it's a good thought. Okay, so I'm hearing a lot of people say that. We can change the base. So then we have this, x, and then we have this. Log of 2 divided by log of 3. That is one way of doing it. That is one way of doing it. That would be a good idea. Never heard that one yet. But here's the problem, guys. Think about this. We have 2 x's. We need to have only 1 x. We've seen this happen before. So you're saying put everything with an x on one side of the equation? Yes. If you put everything with an x on one side, can't you factor out an x and voila? Yes. Okay. So you say everything with an x needs to be on one side of the equation. So I'm going to subtract x from both sides. So now I have 1 is equal to x log of 2 divided by log of 3, and then you have a minus x. And now we've seen this actually a few times this year. If you have an x in common, we can now factor out an x, and that eliminates the problem of having two x's, because now we will only have one. You just got to do it mathematically soundly. 1 is equal to pull out an x, so then divide by x, and divide by x. So then that leaves me with log of 2 divided by log of 3 minus 1. And now we only have one last final step. Divide that, right? Divide, not by x though, but by this. Yes. Divide by that. Divide by that. So my final answer would be 1 over parentheses log of 2 over log of 3 minus 1 equals x. And then that would just be fine. We could then calculate it. The common denominator thing would have worked as well. And then you would have also done the same thing. Got everything with an x on one side and anything else on the other side. Fun fact, they probably wouldn't write it like this in the back of in your answers, but that's okay. Just because, look, we technically have fractions upon fractions, and we could get a common denominator here, then flip and multiply, but yikes. Nah. If this was 1050, I'd say yeah, but nah. Okay, last official example, and then we'll just look at 2 quick story problems, which are really easy. It's the exact same thing, and then we'll be done with the lesson. There's not another lesson, nope. So try one of this caliber by yourself to make sure you are golden. You can, or you can just give me the exact answer. It's not. Good catch. Did you get it? Sweet. Yeah. Right, we divided by x, so then when we divide by x, it becomes 1. Because we subtracted x over, and that left me with negative 3. So now we factored on this side out in x. So then divide both sides by that. Because what does multiplication? Division.
Would the answer want us to, since there's 2 negatives, want to
Careful though, because this is a minus sign, not a negative, right? Okay. Valid questions. All right, let's look at quick 2-story problems, but they're the exact same thing. You need to see that. Okay, so it says, here is the formula for half-life. We've seen this before. Now before, it was just a plug and chug problem. I said to you, how much would be left after 10 years? You'd plug it in for 10, right? 10 is time. Now, this is now going to ask you, it says, how long will it take before 0.9 grams of plutonium-239 is left in the sample? How long will it take? Won't that be solving for t? So this is how much is in the end, 0.9. So you do 0.9 is equal to 1 times a half raised to the t over 24,360. And now you're just solving an exponential equation. So you'd say, I need to get t alone. So I need to isolate the base. So I divide both sides by 1, which is just the same thing, correct? 0.9 equals 1/2 raised to the t over 24,360. Then how would I undo base a half? Log base a half both sides. So now we would have change of base formula, log of 0.9 divided by log of a half, and that's equal to t over 24,360. It's no different. And then we have one last step to get t alone. Multiply both sides by 24,000, right? 360. So then we get this. T is equal to log of 0.9 times 24,360 divided by log of a half. And if you type it in, you get the t is equal to about, it's more than 3,000 years it'll take to get to that. I'm going to try typing it in real quick, because then you can check. $3,702 years, 0.7. So 3,702.7 years. Takes a long time to get down to 0.9. Okay. So let's do one more. This is on the going to be exactly, I bet, how it's worded on the test if I had to guess. Okay, this next one. Suppose you deposit $3,000 into a Roth IRA today. If your deposit earns 8% interest compounded quarterly, how much will be in the account after 7 years? Then it asks, how long will it take to reach $4,500? So we have two problems here. The one is just a plug and chug problem. The other is a logarithm exponential problem. So let's look at it. You do have to have this formula memorized. A is the amount in the end, P is the put down amount, R is the interest rate, N is the number of times it compounds in a year, and T is the time in the account. So let's put in what we know. It says how much will we earn if we have $3,000, so 3,000 times 1 plus our rate is 8%, 0.08 over, N is the number of times it compounds in a year. It compounds quarterly. Isn't that 4 times in a year? So if it would have said monthly, I would have put 12, right? Raised to the 4t. Now it says after 7 years. So that is just a plug and chug problem. Do you see? But the other one says how long will it take? That means I'm going to be solving for t if we wanted to reach $4,500. So now the amount in the end is $4,500. That's equal to 3,000 times 1 plus 0.08 over 4 raised to the 4t. Now from here, guys, look how I'm going to use some algebra to make my life easier. So we would solve for t, divide by 3,000. So then look what I get. That is 1.5 is equal to, I'm going to actually calculate that and rewrite it. If you calculate that, you get base 1.02 raised to the 4t. Now from there, solve for t. Wouldn't we need to undo base 1.02? So we log base 1.02 both sides. So now we have log base 1.02 of 1.5 equals 4t. Change of base formula would be log of 1.5 divided by log of 1.02 equals 4t, and then wouldn't we divide by 4? Boom. T is 5.1 years. It would take 5.1 years to get $4,500. All right, that's the end of the lesson, my friends. Homework, practice the rest of the time. You have 30 minutes.